Hello students, myself Dr. Rupali Vigoyal, working as Assistant Professor in Civil Engineering Department SVIT Vasad. Today I am going to discuss about the topic that is air pollution, which is included in the subject of environmental science, which is common for all the branches and that is generally taught in first and second semester, having subject code 31007. So we will discuss in detail about air pollution topic. So in the topic of air pollution, first we'll talk about structure of atmosphere. Many times in the examination this topic is asked, so that is very important. Next is definition of air pollution and air pollutant. Next is types and sources of air pollution. In that we will discuss major classes of air pollutants, sources of outdoor air pollutants, urban air pollution. Then we'll discuss general effects of air pollution, that is on human being, plants, animals, etc., and general effects. Then mitigation measures, means that is how to control air pollution, that we will discuss. So air pollution is basically related to phenomena that happens in atmosphere. So first we should understand what is atmosphere. So atmosphere is basically mixture of various gases along with some proportion of water vapor. So generally this atmospheric concentration of different gases that you are knowing and that you have studied in your school days also, that is nitrogen, oxygen, argon, carbon dioxide, etc. So these proportions are given. So the composition of these various gases, if it is not maintained properly in your environment, and that is getting disturbed due to addition of different pollutants in the air, either due to natural reasons or either due to man-made reasons, and it is generally responsible for the phenomena which is called as air pollution. So basically it is the disturbance in the natural composition of all the different gases and water vapor, that is generally meant by air pollution term. We will discuss about the structure of atmosphere. Basically the whole atmosphere, it is divided into various layers, and these layers are based on its temperature variation or temperature profile, and based on that it is divided into 5 major layers. First is troposphere, second is stratosphere, or which is also called as ozonosphere, third is mesosphere, fourth one is thermosphere. Basically this thermosphere, it is having two layers, ionosphere and exosphere. So lower thermospheric part is called as ionosphere, and higher thermospheric part is called exosphere. So I will discuss the whole profile, how these layers are classified in this particular temperature profile. So in the on the x-axis the temperature variation is shown, and on the y-axis altitude, or that is height above mean sea level, is shown in kilometer. So basically how the temperature varies as the height increases, that is what which is meant by the temperature profile. So here this may be depending upon the geographical location of a particular place, different temperature profile may be obtained. So here this is the example of one temperature profile. So here at this level, initially the temperature is 20 degrees centigrade. So this thermosphere troposphere region, this is the first region in which we are living, that is having all the pollutants mixing, etc., would take place. So this is having some altitude range, and that range may be ranging from 8 to 16 kilometer. It may be 8 kilometer near the poles and 16 kilometer at the equator. So on an average we can say it is 10 to 11 kilometers. So here temperature in this region, it decreases. So here you can see this temperature profile, at the height increases there is a decrease in temperature. So in this region temperature decreases. Now after some time some pause will take place, means there is no increase in temperature. So that part it is called as tropopause. Pause means ruk jana. So temporarily it is stopped, and now after again that it will again start increasing in temperature, but still it is below 0 degree, you can see this. So next region which is called as stratosphere. So this stratosphere region, it is generally obtained in the range of 45 to 55 kilometers. So on an average here 50 kilometers is shown. So here maximum concentration of ozone is found, which protects our mankind from the harmful ultraviolet radiation. That's why it is also called as ozonosphere. So after a certain time period, that is at reaching around 50 kilometer, some variation in the temperature is ceased, and that is called as stratopause. Now then after again you can see there's no variation in temperature. Next layer which is here, you can see again there is a decrease in temperature. And here this decrease in temperature, it may be in the range of -80 to -90 degree is observed. So this is the coldest region of the atmosphere. Now again similarly the pause is observed, temperature variation is nil, and then after again there is a vast increase in temperature, that is generally termed as thermosphere. So in the lower thermosphere region, which is below 400 to 500 kilometer, there is a presence of some charged particles, and that's why it is also called as ionosphere. And this ionosphere is basically useful for the modern communication system by launching of certain satellites. After that one more layer that is observed, so there is a continuous increase in the temperature, and here the temperature is very high, which may be greater than 1200 degrees centigrade, and which is called as exosphere. So this about this exosphere little is known about that part. So here in this figure, whatever structure of atmosphere I have discussed, the altitude range are mentioned here, and everything I have explained. So this portion is very important as far as exam is concerned, and from environmental point of view that you have to remember is that this stratosphere region, due to presence of ozone, it is very important. Now we'll see what is the definition of this air pollution. So when disturbed atmosphere, that is in terms of the disturbed concentration of different uh, contents or gases which are present in atmosphere, it is basically resulting in the air pollution. So basically, as per our Air Pollution Control Act 1981, air pollution means the presence in the atmosphere of any air pollutant. So we have to understand what is air pollutant. So air pollutant means any solid, liquid or gaseous substance. It may include noise also present in the atmosphere in such a concentration. So concentration is very important, as may be or tend to be injurious to the health of the human being or other living creatures or plants or property or environment. So any solid, liquid, gas substance which present in atmosphere for such a time and concentration that it may be harmful to human being as well as plants, animal and properties also. So these are the chemicals that are generally added to the atmosphere by natural event or human activities in high enough concentration, which are very harmful to human being as well as to other biotic part and abiotic part of the environment. So generally any visible or invisible particles of gas found in the air that is not a part of our original or normal composition. So when normal composition is getting disturbed due to this addition of certain particles or gases, that will result in air pollution. Now we'll discuss types of air pollutants. Basically it is having two categories. First one is based on origin, from where it is originating, and second is based on state of matter. So based on origin there are two types: primary air pollutants. So primary air pollutants are harmful substance that is emitted directly into the atmosphere. So in whatever state they are originating, in the same state they are available in the atmosphere. Next is secondary air pollutants. So these are the harmful substance formed in the atmosphere when a primary air pollutant reacts with the substances normally found in the atmosphere or with other air pollutants. So basically it is due to reaction between the primary pollutant with the other pollutants. So secondary air pollutants they are due to reactions, and primary air pollutants they are directly emitting in the form in which they are originated. Next is based on state of matter. So basically there are two types of state of matter that are resulting in the air pollutant. One is gaseous state, so all the gaseous pollutant. Second is particulates. So generally this particulate pollution, that is suspended matter which is found in at environment. So here in this figure you can see the different primary air pollutants. So this CO, CO2, SO2, NO, NO2, most of the hydrocarbons and most of the particulates that are generally termed as primary air pollutants. And secondary air pollutants, so basically these are resulting in environment due to reaction between the primary air pollutants with the other air pollutants. Suppose this SO2, it is again reacting with the oxygen, then it will be converted into SO3. This H2SO4, that is generally termed as acid rain. So basically this SO3, SO2 converting into SO3 reacting with water, it will result in H2SO4. So basically some chemical reaction would take place, and that will result in our secondary air pollutant. So here you can see this human sources means man-made sources, and these are some natural sources, like this is volcanic eruption that are resulting in different types of primary and secondary air pollutants. Now we will discuss regarding the sources of air pollution. So basically there are two sources of air pollution. First is natural, so like forest fire, pollen grains, dust storm, these are natural source by which thus air pollution is taking place. Second is man-made sources, so generally coal, wood and other fuels that are used in car, home and industries for the energy, that will result in your man-made source of pollution. So generally this source of industrial air pollutants that are major one in man-made sources. So major sources are from the thermal power plant, boiler, thermic fluid heaters, incinerators, cupola, blast furnace, then coke oven, basic oxygen furnace, induction and air furnaces, and cement plants, etc. So these are the major sources of air pollution, that is natural one or either man-made. Also these sources may be classified as point source. So basically point source are those sources which are having some definite origin, and that source it is easy to identify. So some industrial unit is there, so some chimneys that are located and that are regularly discharging air pollutants in the atmosphere, then that kind of point, that is specified one. So example is industrial unit, that is called as point source. Next is line or mobile source. So basically this line or mobile source that are available in a very long chain line, and that is the example are automobile sources. So that is they are polluting in single line, and that are mobile. Next is area source. So basically these are the large sources, so all towns and cities which add smokes as well as gases over wide area, and it is very difficult to find out the or to trace the exact source of this area source. So many sources that are combined in area source, so basically it is large source. So it is very easy to control the air pollution if you are focusing on point source. And also by taking care of this our automobile, we can try to reduce or mitigate the effect of air pollution. So here in this particular figure you can see this natural source, then man-made source, this is from industries. This is stationary source because it is some industrial establishment. This is mobile source, that is moving car, and all are resulting in primary as well as secondary pollutants. Now here these are all the sources of air pollution that are natural sources as well as man-made sources. So here all the list of all natural sources are given, so that you can refer, and as well as these man-made sources, all the sources are given in detail. So here in certain times in exam it is written that list out all the major pollutants. So major air pollutants, here is the list. So first is particulate matter. So all the suspended matter that are generally called as the particulate matter, and here size range is very important. So basically there are two size ranges, and which are also included in the ambient air quality standard, which are called as PM10 and PM2.5. So size which is less than 10 micron meter and size which is less than 2.5 micron meter, this is generally called as PM 2.5. So here in the particulate matter, dust, lead and sulfuric acid, etc. are included, and here the primary or secondary source that is written, and its characteristics are mentioned here. Next is oxides of nitrogen, so that is also the major source, and which is called as NO2. Then sulfur oxides, so that is sulfur dioxide is the major source. Then carbon oxide, so there are two oxides of carbon which are very important, that is carbon monoxide and carbon dioxide, as well as these hydrocarbons. These are also major source of air pollutant, methane, benzene, etc. This ozone, now this ozone is here termed as our air pollutant, but when it is at ground level, then only it is termed as air pollutant. Otherwise if it is present in that stratosphere region, it is very useful gas. Next is air toxics like chlorine. So these are all the list of major pollutants, and you must know these are the major air pollutants which may prevail in our environment, and in particularly atmosphere. So these are the sources of outdoor air pollution. So major sources are transportation sector, and industry, as we have discussed in the main source was also, and then intentional forest fire is also very high. So here all these proportions that are given, that are the major sources, miscellaneous sources are 10%, transportation 57%, fuel combustion except in vehicle is 21%, industrial process 12%. These are all responsible for outdoor air pollution. So that is outside your house. Now, so these major pollutants, carbon oxide, sulfur dioxide, nitrogen dioxide, then particulate matter, then ground level ozone, and hydrocarbons. So these are the list of major pollutants that we will discuss in detail now. So first is carbon monoxide, that is a part of oxides of carbon. So basically this carbon monoxide is colorless and odorless gas. It is produced when carbon does not burn completely. So basically it is the result of incomplete combustion in fossil fuel. पूरा नहीं जलता है और incomplete combustion होता है तो carbon monoxide पैदा होता है. So it is generally present in exhaust, car exhaust. So if incomplete combustion take place, then it will produce during this exhaust, then a deprived body of oxygen by formation of the carboxyhemoglobin. Now this is the effect. When this carbon dioxide, if it is inhaled and it is combining with the oxygen by formation of it will form the carboxyhemoglobin, and which prevent the blood from carrying the oxygen. So oxygen reducing capacity, it is reduced, and it has 200 times more affinity towards the blood. So this carboxyhemoglobin is very dangerous, and that may result in cardiovascular disease also, and that may result in ultimate death also. It may cause headaches and dizziness, fatigue, and impaired vision also. So this is a very dangerous kind of pollutant, which is termed as carbon monoxide. Next is carbon dioxide. Basically this carbon dioxide, it is not that much harmful as carbon monoxide, but generally it is a greenhouse gas, and this greenhouse gas, it is resulting in global warming. Next dangerous gaseous pollutant is sulfur dioxide. This gas is produced by chemical interaction between sulfur and oxygen. It produced when coal and fuel oil are burned together. So generally it is found in the power plant exhaust. So effect wise, it narrows the airways, it causing the wheezing, that is breathless, and shortness of the breath, especially in those persons who are suffering with asthma. Also they are responsible for acid rain. So this SO2, SO2 combining with oxygen and water, that will result in acid rain. Now we'll discuss about nitrogen oxides. So basically it is reddish brown color gas. It is producing when nitric oxide combines with oxygen in the atmosphere at high temperature. It is present in car exhaust, as well as you may find it in power plants. So major problem with this oxides of nitrogen is that it is also one of the major greenhouse gas. It cause difficulty in breathing and affect lungs and cause wheezing and increase the chances of respiratory infection. Now next important pollutant is particulate matter. So thousands of different solid or liquid particles that are suspended in air, like soil particles, soot, then lead, asbestos, sea salt, and sulfuric acid droplets, all which remains in suspensions, that are generally called as particulate matter, and that are present in many sources, including fossil fuel dust, smoke, fog, etc. So as I have discussed, there are two types of particulate matter which are of major concern as far as the pollution is concerned. That is SPM, that is suspended particulate matter, which is generally termed as PM10. This 10 represent the size in 10 micrometer, and then next is PM 2.5, so size which is less than 2.5 micrometer. Basically this PM 2.5 is more dangerous as compared to PM 10, because this size is very small, so it will pass through the hairs of the nose, and that may reach up to the last point of your lungs, that is up to alveoli, and that is affecting the whole system of your lungs. So this is very dangerous. So it is dangerous for two reasons. It may contain materials with toxic or carcinogenic effect. Carcinogenic effect means it may result in cancer. So this is very dangerous. Extremely small particles can become lodged in lungs. So this PM 2.5 that are very small in size, and that will result this maximum concentration in the lungs, and that will affect it. It aggravates the heart and lung disease, and it can build up in the respiratory system and increase the risk of respiratory infection. So this particulate matter that are very dangerous kind of pollutant if they are present in atmosphere. So next pollutant is ozone. So there are two types of ozones that are present in atmosphere. So first is tropospheric ozone, which is termed as ground level ozone. So this is basically ground level ozone is considered as pollutant, and it is man-made pollutant, and that is secondary, that is due to reaction between oxygen and molecules of oxygen. That component of it is a photochemical smoke. So basically it's a secondary pollutant. And the stratospheric ozone, so here this is very useful ozone, so this may not be considered as pollutant, and but that man-made pollutant like CFCs that are destroying it, and that is reducing our ozone layer in that stratospheric region, and that is what which is meant by the ozone layer depletion. And that is why all this UV radiation that are coming to Earth's surface in larger proportion, and that are affecting our human health by aggravating the situation of skin cancers, cataracts, etc. So ground level ozone is generally considered as harmful pollutant, and generally it is formed from car, power and chemical plant exhaust. So basically it is a secondary pollutant which is produced by the photochemical reaction between NOx and volatile organic compound in the atmosphere. So it is also very harmful. It causes the breathing difficulty and aggravate the lung disease such as emphysema and the chronic bronchitis. It irritates the respiratory system and reduces the lung function by inflaming and damaging the lining of lungs. So it affects lungs, it affects your particular breathing, and it result in the disease which is called as the chronic bronchitis. These hydrocarbons, they are the diverse group of organic compounds that contains only hydrogen and carbon. For example, CH4, that is methane, acetylene, ethylene, terpenes, etc. Some are related to photochemical smoke, that is secondary air pollutants, and which results in greenhouse gases also. Some are carcinogens. So whenever the word like carcinogen is there, that is very dangerous, that may result in cancer. Now we are talking about urban air pollution, which is widely found in urban areas, and that is due to photochemical smog. Here the example of Los Angeles is shown in the figure. So here you can find the brownish orange haze which is formed by the chemical reaction involving sunlight. So here there is a presence of sunlight, then nitrogen oxide and hydrocarbons. When all these three are combining together, then it will result in photochemical reaction. Photo, that is related to light, chemicals means the reaction with this nitrogen oxide and hydrocarbons, and presence of smoke along with fog. So these are all the combination of the words that will make the word like photochemical smog, and that is very dangerous kind of air pollution nowadays found in urban cities. And here in this you can see this kind of brownish orange haze which is formed due to this photochemical smog. So basically this photochemical smog is the example of secondary air pollutant. In this figure, how this photochemical smog are formed, that is shown here. So here the sources of air pollutants, that is from the man-made sources, carbon dioxide, then hydrocarbon, and here this is nitrogen oxide combining with oxygen, so that will result in nitrogen dioxide. So this reaction in the atmosphere, that is shown for the different air pollutants which are coming from the troposphere region. Then here in the presence of sunlight, the different secondary pollutants that are resulting here, this nitrogen dioxide react with water, and it may result in nitric acid in the presence of sunlight, as well as this peroxyacetyl nitrate if it is combining with molecular oxygen and hydrocarbons. So these pans that are nothing but secondary air pollutants. Then this hydrocarbon combining with oxygen, that will result in formaldehyde, ozone. This is also photochemical smoke. So these are all secondary air pollutants which are formed And why it is photochemical? Because in the presence of sunlight reacting with the different chemicals, and that are resulting in smog. Smog is nothing but it is combination of two words, smoke plus fog. So this smog is nothing but it is a combination of smoke plus fog, and that is secondary air pollutant. It is combination of gases with water vapor and dust, and it forms when the heat and sunlight react with the gases. So that's why it is called as photochemical smog, and occurs when there is a heavy traffic, that is generally found in urban areas, high temperatures and calm winds. So its effect are very dangerous. So first smog related death was observed in London in 1873. That is called as London smog, and that toll was around 500 people. So due to this photochemical smog, the visibility reduction would take place. It decreases the UV radiation. Yellow or black color is observed over cities, and also it result in the respiratory problems, and this bronchial related deaths are generally observed. So this photochemical smog is becoming nowadays major problem in most of the cities. That's why it is also termed as the urban air pollution. Now we'll discuss about how this air pollution is measured, because if you are not measuring the quantity, then you won't be able to know how much your air is polluted. So to measure this air pollutant, one index which is called as air quality index word is utilized. So basically it is a number used by the government agencies to communicate to the public that how polluted the air is currently, and how polluted it will be forecasted. And as the AQI increases, that is you have to concern about the large percentage of population is likely to experience increase, and the increasingly severe adverse health effects are going to be observed. So if AQI, air quality index, that is combination of the different air pollutants, if it is less, then good quality air, and if it is more, then it is the quality of air is not good. So here some measures are given. So air quality, if it is considered good, then air quality index should be in the range of 0 to 50, and protect your health, means no health impact are expected when air quality is in this range. So this is considered to be the best air quality index, 0 to 50. If it is in the range of 51 to 100, then it is considered to be moderate. So it will generally affect the sensitive people, and they should consider limiting prolonged outdoor exertion. Unhealthy for sensitive groups, that is air quality in the range of 101 to 150. So children, adult and people with the respiratory disease, they should take care. Those who are having asthma, they have to limit themselves to the outdoor exertion. Then unhealthy air quality, that is considered from 151 to 200. So these children, adults and all the sensitive people, they should keep themselves away from the outdoor exertion. And unhealthy or very alert condition is observed that when this air quality index is in the range of 201 to 300. So this is the severe condition, and that will affect many people. So already we have discussed a few effects of air pollution. So this is general effect. If low level exposure is there, then it will irritate your eyes. It will cause the inflammation of respiratory tract. Means your respiratory tract, you may find some inflammation in that. It can develop into the chronic respiratory disease. So all the sources as well as effect for the different pollutants that are again given just as a summary. And most of the cases you may find that air pollution, it will affect right from your head to up to your lung. Here just the summary of different health effects of different air pollutants are given. Sulfur dioxide and particulate material that will irritate respiratory tract and impair the ability of lungs to exchange the gases. Nitrogen dioxide, it will causes the airway restrictions. So airway restrictions, so again it is breathing problem. Then carbon monoxide, as I discussed, that will bind with the iron in the blood hemoglobin, and it will form a carboxyhemoglobin, which will reduce the oxygen carrying capacity of your blood. Then it cause headache, fatigue, drowsiness, and even death in extreme cases, ozone that causes the burning eyes, then coughing and chest discomfort. These are all the general health effects of air pollution. So what's the relation between children and air pollution? So greater health threat to the children than adults, and this air pollution can restrict the lung development. So that is the major impact which can be observed on children. Children breathe more often than adults, and children who live in high zone of ozone area, they are likely to develop asthma, because the breathing cycle of children, that is more, so more air and more oxygen they are inhaling, so they are more affected with this air pollution concern. So in this figure, all the different effects, right from, as I told you, that it will start from head and that will reach up to your lung and chest. So it may result in dizziness, headache, eye irritation, nasal nose or nasal irritation, coughing and shortness of breath, sore throat, then possible lung cancer and other lung diseases, chest pain, etc. It may increase cold and allergies. So this way also you can draw the figure and you can explain the general effects of air pollution on human body. So here also similarly the different effects are shown. To summarize this is fine particle PM 2.5, which is very bad, and that may cause all this effect. So right from your so only up to chest you have to consider all this effect. Now this COPD, which is called as the chronic obstructive pulmonary disease, is a common lung disease, and having COPD makes it hard to breathe. And there are two main forms of COPD, that is chronic bronchitis, which involves a long-term cough with mucus, and emphysema, which involves the damage to lungs over a time. So this COPD, this is very dangerous effect that may be observed, and that is due to presence of ground level ozone. So all these are summarized in this particular figure, so you can refer this figure for knowing the general health effect right from your head to your chest. So as this air pollution or air pollutants are affecting human beings, similarly it affects on effects on plant also. So these general pollutants and effects on plants are given. So this, if SO2 is in excess proportion, then it may result in the bleaching of leaves, means its color that is reduced, so green color. Instead of that you may see some yellow color or like that. Necrosis is nothing but killing of tissues of plants. If excessive proportion of NO2 is present, then it suppresses the growth, so growth may not take place properly, and bleaching, that is color is not found proper. Then ozone, if excessive ozone is present, again it will affect the growth of plants. Bleaching effect, necrosis means cleaning of tissues, and collapse of leaf, so the whole leaf may be collapsed due to this presence of ozone. Then if excessive fluoride is present, then necrosis at the tip of the leaf may take place. If PAN, that is peroxyacetyl nitrate, secondary air pollutant, it will also suppress the growth and silvering of the lower leaf surfaces. So here some of the figures that are shown, that is necrotic lesions on the lower surface of the potato leaves. So this killing of tissue takes place. Chlorosis and necrosis of the, chlorosis means reduction in the chlorophyll content, and this is necrosis of the watermelon leaf is shown in this figure. Also this air pollution will affect on material. So the particulate matter causes the damage to buildings, and the corrosion is enhanced. So kat khai jau, that is rusting, that is the major problem which is observed. It causes cracks and fading of the painted surface, not pointed, it's a painted surface. Then particulate accumulate on the soil and reduce the fertility of the soil. Now the major impact that is observed, that is the effect of acid rain on Taj Mahal. So here this figure, this beauty of the monument, that is taken away due to effect on the material. So here this effect of material, the sulfuric acid will attack the building material containing carbonate, and this will form CaSO4, and this CaSO4 gets easily washed away and leaving the discolored surfaces. So some coloring substance that will be taken away along with this CaSO4, and that will reduce its beauty. Then paper absorb SO2, causing the paper to become brittle. so that brittle paper that may be due to effect of SO2. Then leather loses the strength and flexibility. So there are many effects that are observed on material also, that are generally termed as economic effect. Now we'll talk about some air pollution around the world. So this air quality is deteriorating rapidly in developing countries. China, one city is there which is called as Shenyang. Here the residents can only see sunlight for a few weeks each year. In these developing countries, the problem is aggravating due to use of older cars which still uses leaded gasoline. Now 5 worst cities in the world, they are Beijing, China, Mexico City, Mexico, Shanghai, China, Tehran, Iran, and Calcutta in India. So this air pollution concern is increasing day by day in all the major cities all around the globe, and this control, if it is not done properly, then it is resulting in all the global issues like global warming, acid rain, and ozone depletion. Similar to urban or outdoor air pollution, there is a word which is called as the indoor air pollution. So that air pollution which is formed inside your house. So these pollutants can be 5 to 100 times greater than the outdoor air pollutants. So most common air pollutants which are found are radon, cigarettes, smoke, carbon monoxide, nitrogen dioxide, formaldehyde, pesticides, lead, cleaning substance, ozone, and asbestos. So in this figure, all the possible sources from where these different pollutants may enter inside your house is shown. Apart from the major all the health issues and economic effect and effect on plants and animals, the other problems are also there that we are facing today due to air pollution. So the other effect includes greenhouse effect that is widely found in nature. Okay, and this greenhouse effect is resulting in global warming all over the globe. The temperature is increasing. Next is thinning of upper ozone layer, that is very essential as far as the harmful UV radiation is concerned. So this ozone layer is also depleting due to air pollution itself. Now next, that is acid rain. So this acid rain is also killing many people, plants, animals, etc. So basically, to control this air pollution, we are having certain environmental legislation available with us in India. We are following this act that is called as the Air Prevention and Control of Pollution Act 1981. And as per this, the ambient air quality standards are given. So here these are the national ambient air quality standards given by CPCB, that is Central Pollution Control Board, in the year 2009. So here all the pollutants that are given, so all the major pollutants that we have discussed, they are there: SO2, NO2, SPM, suspended particulate matter, respirable suspended particulate matter. These are nothing but this is PM 2.5, ozone, lead, etc. So time weighted average, annual average, as well as 24-hour average are given. Then concentration in the ambient air that are given. There are two categories in this. First is industrial area, residential area, rural and other areas, and next is ecological and sensitive area. So the limits given here, you can see in the ecological and sensitive area it is less as compared to industrial or residential zone. So for SO2, the limit for annual average is 50 microgram per meter cube, and for ecological and sensitive area it is 20 microgram per meter cube. So similarly, the limits are given for both the categories, and for two measurements for all the major pollutants. Here carbon monoxide, ammonia, benzene, then benzopyrene, particulate phase only, then arsenic, nickel, etc. So these are the limits that are to be followed if you want to maintain air pollution within limits. So national ambient air quality standards are generally followed in India. Now up till now we have discussed about the problem and its effect. Now if you want to control that, then that measure is generally called as the mitigation measures. So mitigation measures are nothing but all the measures that we are taking to prevent, reduce, or control the adverse environmental effect of air pollution. So how to control or how to mitigate all this air pollution? So basically this mitigation measures or controlling air pollution is applied for the industrial establishment. So in the industrial establishment, There are two types of control measures that are widely used to control the particulate matter, that is PM10 and PM2.5, and control of gaseous pollutant, all the different gases that we have discussed. So in the control of gaseous pollutants, the different methods used are absorption by liquid, adsorption by solids, condensation method, combustion or incineration just by burning. But for the control of particulate matter, industries, they have to install certain equipment that are called as gravity settling chambers, cyclone separator, fabric filters, electrostatic precipitator, wet collectors and scrubber. So we will discuss in brief about all the control of particulate matter using all these equipments. So first one is gravity settling chamber. So this figure shows the gravity settling chamber. So basically it is consist of the rectangular chamber, and in which the several horizontal trays are provided. So this is the horizontal chamber, and here it use the force of gravity to remove the solid particle. So when this raw gas which is entering inside your chamber, its velocity is more, and when it enters here, due to large surface, its velocity is reduced, and as the velocity is reduced, the large particles that will drop out in the bottom collection hopper. So this large particle drop out of gas and settle down in the hopper, and then they are collected. Generally it is limited for the removal of particles larger than about 40 to 60 micrometer diameter. Hence, so if you want to remove a small particle in the lesser size range, then it is to be removed with the help of other efficient device. So only gravity settling chamber cannot be utilized. So here at the outlet, once this particulate matter dropped, you can get the clean gas which is free from particulate matter. Here this is the real figure of one such a gravity settling chamber in industry. The next unit is called fabric filter or baghouse filter. So basically it is the device that remove the particulate from the gas stream by passing the dirty air through a layer of cloth filtration. So here in this figure you can see this is the fabric filter or the cloth. From the center the air will enter, and as this fabric filter, it is having very less pore size, this will filter air, and all the dust particle that will deposit on the cloth surface area, and leaving only clean air to pass through. So as this buildup of the suspended matter takes place inside the fabric filter, it will increase its efficiency once it is used for the cleaning purpose. So number of bags are provided inside this bag house, and once it is getting chalked up by the shaker mechanism, by shaking it, this all the dust particles that are removed, and again you can utilize for the next operation. So efficiency of collection may be obtained at 99 to 99.9% with the particle size having 1 micrometer also. The next equipment is called cyclone separator or cyclone. So they are generally separation device which are called as dry scrubbers that uses the principle of inertia to remove the particulate matter from flue gases. Cyclone separators generally used for removing the particle in the size range of 10 micrometer in size. But however, conventional cyclone, which seldom removes the particles with the efficiency greater than 90% unless the particle size is 25 micrometer or larger. So here how it works. So this dirty gas which is consisting of the dust, that will take from this that will be taken from the outside, from the top, and this will take a vortex, that is outer vortex. Now here inside this, the second small pipe is provided. So second vortex will be formed, and that is inner vortex. So and that's filling action of the air that will be formed. While doing this vortex formation, all the dust particle that will be stick to the surface during this vortex formation, that is outer vortex as well as inner vortex, and clean air is coming out. So this cyclone is formed in the two vortex system, outer and inner, and all this particulars stick out, that dust particles that will be collected at the bottom, and this dust collector that will be taken out for the removal purpose. So here there is a figure of cyclone separator which is shown in this figure. Next unit is electrostatic precipitator. This static precipitator removes the suspended particle from gas by applying a high voltage electrostatic charge. So basically it works on the principle of electrical charging of particulate matter, which are negatively charged and which are collected in positively charged surface. So here in this figure you can see that this is one electrostatic plate. So here from this dirty gas is coming inside this central one, that is electrode, which is negatively charged, and this precipitator wall, it is positively charged particle, positively charged. So all these particles which are negatively charged, they will be in the presence of the electrostatic high voltage charge that will come on this particular wall and stick to that, and that will be collected at the bottom. So here you can obtain high collection efficiency up to 99 to 100% over a wide range of the particle size, that is very less size also, 0.05 to 5 micron meter. So here in this figure you can say that you can see this there's a how much amount of particulate matter that are generated, that is without electrostatic precipitator, and a smokestack with the electrostatic precipitator which is provided at right, it is having less amount of particulate matter. So this figure, it shows the working principle of this ESP. So this is gas flow. These are uncharged particles which are present. This collector electrode, that is the wall surface, that is acting as a collector plate, that is positive polarity, and these all are negative polarity charge particle. They will go towards this particular wall on the collector plate, and once they are collected and once they are attracted, and they will stick to this outer wall, and then this clean gas can be taken out, and all this particular particle which are attached to the wall, that can be collected later on. So this way, this is the principle of ESP that you can explain in exam. Next unit is wet scrubber. So this wet scrubbers that are working on the principle of the liquid spray, so which is used to remove the dust particles from the gaseous stream. So here in this figure you can see that from bottom this dirty gas is provided in the upper direction, that also contains suspended matter, and at various level the spray of the liquid is done. So when we are doing this spraying of the liquid particle, all the gases particulate matter that are along with the water, that will be collected at the bottom. So the exhaust gas which is without particulate matter, that is called as the clean gas, that can be collected from the upside. So the exhaust gas is passed in the column from downside, and scrubbing or solution material is sprayed at the top. So here generally the liquid, that is water, is used as a scrubbing medium, and along with this water all the particulate matter that can be collected at the bottom, and that can be removed, and you can get clean gas, that is not containing particulate matter. So at last we will discuss all the general mitigation measures or the control measures to reduce the air pollution. So to reduce the global impact of this air pollution, so to move away from the fossil fuel, replacing them with the alternative energies like solar, wind and geothermal. So widely in India also now we are moving over to this alternative energy source. Next is planting more trees, that is very useful, reducing vehicle exhaust. Then using the mass transport system, industrial area should be away from the residential area. Use of the tall chimneys or stack to be adopted to reduce the concentration of air pollutants and ground level. So these are some certain general mitigation measures that are to be adopted to reduce air pollution. So with this I would like to end my lecture. So plant more trees, go green, and thank you very much. I hope that whatever contents I have shared today, that it will be useful to you for your examination. Thank you very much all students.